Hello, everyone. I wanted to make a couple of quick videos for you to help with some homework 8 stuff. I know that you've got a lot to do this weekend, figuring out homework 8 and preparing for test 2 on Monday. So I wanted to make sure you had a few short videos to help you along so that you could use your time as efficiently as possible. So in this video, we're going to do a polynomial inequality example. I kind of went through this quickly during class on Wednesday, and that's because this process matches quadratic inequalities exactly. Um, so hopefully you should be familiar with this process, but we only did one example in class, so I wanted to go through this as well so you had another example. So to solve polynomial inequalities, the first thing that you're going to do is replace your inequality symbol with an equal sign. And I want you to solve the equation first. The solutions that you get out of the equation, you're going to put those on a number line and cut it into pieces. And then once you have that cut into pieces, you're going to choose a test value from each piece of your number line and plug each test value into your original inequality to see if it works or not. If the test value works, that whole part of the number line works. And you can use any test value in that whole section that you want. All of the values in there are going to work the same way. You can pick whatever you want. Just make sure that your test value is in that piece. I find especially with negative numbers, it can be more of a challenge to make sure that your numbers are in the right spots. So, yeah, test your test values in the inequality and then write your answer and make sure you include all of the pieces that work. Okay, so we did number 1 here in class. That one was factored for you. I wanted to do number 2 here so that you could see one where you had to do some factoring yourself. So let's start with number 2 here. So the first thing we're going to do is change our inequality symbol to an equal sign. So we'll have x to the third plus 4x squared equals negative 4x. Just change the inequality sign here to an equal sign, and we're going to solve the equation first. Okay, so to solve this equation, I'm going to put everything on one side and get a 0 on the other side because we've got a lot of x's going on here. So I'm going to add that 4x to both sides. So I'll have x to the third plus 4x squared plus 4x is equal to 0. Now, to try to solve this out, I'm going to factor on the left-hand side. First thing that you're going to do with factoring is see if you can take out a common factor. An x will come out of all of these things, so I'm going to take that x out, and I will get x squared plus 4x plus 4 equals 0 when I take out my common factor of x, and then I can factor this further. So my leading coefficient is 1 here. So a times c, 1 times 4 is 4. I'm looking for two numbers that multiply to 4 and add to our middle number b here, which is 4. Two things that multiply to 4 and add to 4, that's positive 2 and positive 2. So this is going to factor into x times x plus 2 times x plus 2. Again, I can just take these two numbers that I have and pop them into my parentheses with x's. That's because my leading coefficient is 1. If your leading coefficient is not 1, you have to split your middle term, chop it in half, and then factor by grouping. Okay, so we now have this thing factored. We've got x times x plus 2 times x plus 2. So we're going to set each factor equal to 0. So either x equals 0 or x plus 2 equals 0. Since I've got two of the same factors, I'm going to get the same thing either way. So I'm only going to set x plus 2 equal to 0 once. So the solutions that I get out here are x equals 0 or x equals negative 2. These are my solutions, and I'm going to put those on a number line. So negative 2 is over here, and 0 is over here somewhere. And these two numbers are going to cut my number line up into 3 pieces. So now I'm going to choose a test value from each piece. It does not matter what numbers you pick, just make sure they're in the right spot. So a number that's over here to the left of -2, that's less than -2, I'm going to pick x equals -3. Here in the middle, I'm going to pick x equals -1. That's between -2 and 0. And here on the right, I'm going to pick x equals 2. And so now we just need to take each of our test values and we are going to test them in the original inequality to see if they work. So when I take -3 and plug it into my inequality, I get -3 to the third power plus 4 times -3 squared. And my inequality says that should be less than -4 times -3. So now we've got to do some arithmetic here to see whether or not this is true. So -3 to the third power, that's -27, plus -3 squared, that's 9, +9. +9 times +4, that's 36. And that's going to be less than -4 times -3. That's a +12. So -27 plus 36, that gives me a +9. And that should be less than 12. That is, in fact, true. So this piece works. And then let's test our next piece here. So if I take -1 and plug it into my equation, or sorry, not my equation, my inequality here, I'm going to get -1 to the third power plus 4 times -1 squared. My inequality says that should be less than -4 times -1. So let's see here. -1 to the third power, that's -1. -1 squared, that's a +1, times +4, that gives me a +4. And that should be less than -4 times -1 is a +4. So when I simplify here on the left, -1 plus 4, that's 3. This says 3 is less than 4. That's true. So this part works as well. Okay. And then finally, let's check 2 here. So if I take 2 and plug that in, it's my inequality. I'm going to get 2 to the third power plus 4 times 2 squared. That should be less than -4 times 2. 2 to the third power is 8, plus 2 to the second power is 4, times 4 is 16. That should be less than -4 times 2 is -8. Simplifying on the left, 8 plus 16, that is 24. My inequality says that should be less than -8. That is not true at all, so this part does not work. And this kind of stuff can happen with polynomials where we have two sections in a row that work. This doesn't happen as much with quadratics, but it can happen with polynomials. So make sure you test each piece and you don't assume they're just going to alternate, like work, not work, work, not work. So now we have to write our solution. So everything here to the left of -2 works, and everything here between -2 and 0 works. So my solution here, let me switch back to blue. My solution here is going to be anything from -infinity to -2, and anything from -2 to 0. Now, infinity always has an open parenthesis here. And then how about at -2 and 0? To figure out whether those are parentheses or brackets, I'm going to come back here and look at my inequality. Since I don't have the little equal to sign, it's strictly less than, these are going to be parentheses. I do not want to include those endpoints. So this is my solution. So I wanted you to have another example where you factored. and where you saw that these guys aren't going to alternate all the time. So make sure you test all of your pieces. And then one quick thing I wanted to mention here in the next one. So let's just run through number 3 real quick because I want to show you something specific here. So if we were solving this one, the first thing you're going to do is change that inequality symbol to an equal sign, right? So we're going to solve the equation first. This is factored for us, so we just have to set each factor equal to 0. So either x minus 1 equals 0 or x plus 3 equals 0. So x is equal to positive 1 or negative 3. So we'll put those on a number line. Negative 3 is here, positive 1 is here. And so now we just have to test values in our original inequality. So I'm just going to pick some here. X equals negative 5, x equals 0, and x equals, 2. And so when I plug these in to my inequality right here, negative 5 minus 1, that's negative 6 squared, times negative 5 plus 3, that's negative 2. That should be greater than or equal to 0. And so this is 36 times negative 2. This says that should be greater than or equal to 0. But negative 72 is not greater than or equal to 0. This part does not work. When we plug in x equals 0, we get negative 1 squared times 3. My inequality says that should be greater than or equal to 0. Negative 1 squared is a positive 1 times 3 is a positive 3. That is, in fact, greater than or equal to 0, so this guy works. And when I plug in 2, I get 2 minus 1 is 1 squared times 2 plus 3 is 5. And my inequality says that should be greater than or equal to 0. 1 squared is 1 times 5 is 5. That is, in fact, greater than 0. This guy works. Okay, so now we know what works, and we can write our final solution. So when we do that, we'll have everything between negative 3 and 1 works, and everything from 1 to infinity works. Infinity is open. When I go back to check my inequality symbol here, I do have the equal to sign here, and that means I'm going to include all of my endpoints. So this is the solution here, and this is what works. Now, the thing about this is, if we graph this on the number line, I think it's easier to kind of see why we take the next step here using the graph as well. So if I would graph this, we include our 2 endpoints here. We're going to include everything between them that works, and everything to the right over here works. Just nothing here to the left of negative 3. And so do you see that really when we put these two pieces together, because we include this 1 here, really everything from negative 3 on up works. Since this one is repeated and it works, this whole thing is the same thing as the interval from negative 3 to infinity. I can write this as a single interval instead of a union of 2 other closed intervals. Sometimes Alex might force you to write it as 1 interval instead of 2, and that can be a confusing thing for some students. So I wanted you to kind of see an example to figure out why that is, and why sometimes we can write it with 1 interval like we can down here, but back up here in number 2, we couldn't write this as a single interval here because this number at negative 2 was not included. We did not include our endpoints here. And so what that means is that this does not include everything less than 0 because we have to cut negative 2 out. So we can't write this as a single interval, but we can write these two as a single interval. We can combine those. Okay, hopefully that helps with inequalities. I'm going to make a couple more videos, one to help with polynomial long division, and another one to help with the factor theorem and the remainder theorem, which we didn't have a chance to do in class. So I'll see you in the next video. Have a great day.